In this video, we're going to do example 5, and we're going to be using L'Hopital's rule twice to evaluate this limit. Because we're going to use it twice, I'm going to set up my Scratch to run vertically over here. All right, so 1, in example 2a, we showed that we had this indeterminate form of infinity over infinity. 2, the numerator and the denominator functions are differentiable. Okay, let's go ahead and take their derivatives. Chain rule on f, we have e to the 3x times 3. And power rule on g, we got g prime is 2x. All right, and then 3, the derivative of the denominator function is not 0 for x values near where we're approaching, in this case, infinity. And that's definitely the case. The derivative of the denominator is only 0 at 0. All right. So by 1, 2, and 3, we can use L'Hopital's rule. All right, and let's go ahead and do that. The limit as x approaches infinity of e to the 3x over x squared. I'll get my color straight. By L'Hopital's rule, that's equal to the limit as x approaches infinity of 3x. Sorry, I can't. 3e to the 3x all over 2x. I was thinking about space. Excuse me. So notice now, as x gets big and positive, we still have this indeterminate form. E to the huge is huge, times 3 is huge, and 2 times huge is huge. So we're going to go through and do the Scratch right below here for using L'Hopital's rule a second time. A little bit more Scratch. The limit as x approaches infinity of 3e to the 3x all over 2x is also indeterminate. Let's just see that. This is on its way to 3 times e to the 3 times huge over 2 times huge. Which is 3 times e to the huge over huge, which is huge over huge. Okay. My numerator function and my denominator function are differentiable. My numerator function and my denominator function are differentiable. purple. Derivative of the numerator is 3 times e to the 3x, chain rule times another 3, 9e to the 3x, and the derivative of my denominator is just 2, which is never 0. In particular, it's not 0 for x being really big and positive. Get the same color there. There we go. It's not 0. I'm just going to leave it at that. And so by 1, 2, and 3, we can use L'Hopital's rule again. Okay. Maybe I'll put this right there. That looks a little better. All right, so by using L'Hopital's rule again, that's the limit as x approaches infinity of 9e to the 3x all over 2. And now we don't have an issue with plugging in. Where is this on its way to? This is on its way to 9 times e to the huge all over 2, which is huge over 2, which is just huge. All right, and we are done. Okay, so the scratch on this one, I'm being very formal here, but it is important to know that you can use the rule before you just jump ahead and use it. This result shouldn't be too surprising. Although we have an infinity over an infinity form, e to the 3x grows so much faster than x squared. The numerator is dominating here. Let's go ahead and look at the graphs of my function, each one of these, the green one, the pink one, and the purple one. Although these are each separate questions, they have the same answer because they have the same end behavior. All right, so we were asked, as x gets big and positive, what does e to the 3x over x squared do? And you can see that those y values are getting real big and positive. That's also true for this function and for that function.